through about the different types of solving a probability question. Okay, and we stopped at, okay, which are the methods that can be used to solve the probability question? So let's ask. Okay, Javier, what are the types? Don't know. Table. Okay, drawing a table. What else? Nikki? Huh? Venn diagram, which I have not gone through yet before. Okay. The red t-shirt guy, one more method. Yeah, you, I'm looking at you, yes. Okay, possibility diagram. Okay, so the two possibility diagram and table is what I went through. So today I'll go through a Venn diagram. Okay, so let's read the question first. Alright, so let's recap. So there are a class of 25 students, 20 of them study at least one subject, physics or biology. 15 of them study physics, 12 of them bio. For a probability that the student study physics and bio. Please take note of the 15 of them, right, study physics, right? It's not only physics, it can be physics and some other subject. These 12 of them, bio one, it's not just study bio only. The keyword is only, they never say. Right? It can study biology and physics. You know what I'm saying? Right? So here, I remember telling you that you need to define the events. It's already been defined for you, so whenever you do your tutorial, you need to define. It's much easier for you. Okay, so let's say A is for physics, B is for biology. Okay. Then my small letter RST is physics only. Physics only is R. Biology only is S. And both physics and biology is T. Okay. So this is how I illustrate this on my Venn diagram. R here is just only this part. Okay, this is for physics only. The green part, the center is physics and bio. Okay, what else? The blue part here is only for biology only. Okay, is that clear? Okay, so without further ado, okay, let's find what is my R, S, and T. Okay, so from the question, right, R plus T plus S, there's space. You please write that down. You write slightly smaller, my handwriting is a bit big. So R plus T plus S is 20. Because they say 20 of them study at least one subject, physics or bio. So must study, right? Okay, so R, T, S, either physics and bio or bio. Okay, so R plus T plus S is 20. Okay, how about the 15? 15 study physics. So physics is just R plus T, just 15. Okay, so in this part, the A is R plus T, this is 15. Okay, how about the 12? 12 then study bio. So bio is where? So it's just the Venn diagram, it's just the event B, right? Here, event B. So it's T plus S is 12. Okay, you notice that I written down this for you in this manner, okay, because I'm going to solve simultaneous equations. Is that clear? Okay, so simultaneous equations. So solving them, three unknowns using your GC. Okay, you should get your R to be 8. Yes, R to be 8, your S to be 5, your T is 7. Alright? Okay, so with that, okay, what is the question asking? Find the probability that a student chosen study both physics and bio. So they want the physics and bio. So they want the probability A intersect B, okay, would be only 7 students study physics and bio out of a total of 25. Agree? Out of total 25. So this is the answer. Okay? Sorry, let me write down something. This is the number of elements in A intersect B divided by the number of elements in the sample space. Okay, so this is 7 out of 25. Okay, clearer for you. Okay, alright. Any question at this point in time? Okay, so far so good. Okay, let's move on to the other method. Okay, using. Do I need some more time to write? Okay, quickly. Okay, let's move on. So using P and C. Sometimes in your PSC tutorial, they always ask you find the number of ways. But in probability, they'll ask you what is the probability. Okay, so what you should be doing is this. Okay, so let's read the question. Okay, a committee of 5 is formed from a group of 9 people consisting 3 boys, 4 girls, a brother sister pair. So in total, how many boys are there? 4 boys and 5 girls. Okay, because the brother and the sister pair. Okay, and they want 5 of them. So in part 1, okay, what is the probability that the committee include the brother sister pair? So this is for part 1, include the brother sister pair. And they want the probability. I highlight the probability for you. Okay, so this is exactly the same as your PNC example, right? You still recall this example? This is your PNC example that I went through it with you. But in this case, we want probability. So first thing first, must find out the case where there is number of ways to form a committee without restrictions. Okay. So how to form a committee without restrictions? The 9 choose 5. Okay, 1, 2, 6. So this is the without restrictions. Okay. Okay. So let's find our probability. Brother, sister is inside. Brother, sister is in. Select 3 from the remaining 7 people. Why? Because I want 5 people. Brother, sister already inside. How many more you need? Wait, don't jump. So 5 people, brother, sister pair is inside. You need 3 more, right? Okay. So something choose 3 more to form the committee. There are originally 9 people, right? Your brother, sister already inside. So you left with 7. Okay. So 7 choose 3. Okay. So this is equal to 35. So the required probability will be the 35 divided by the no restriction case, which is 126. Is that clear? Okay, so this is the probability that you need. Alright. Okay, so this is for part 1. So far so good? Okay, so let's move on to part 2. A particular girl is not in the committee together with a particular boy. I remember going through this with you using the complement method. Okay, so let's read. If I use the complement method, what case I don't want? What case I don't want? The particular boy and particular girl is inside the committee, right? This is what you don't want. Okay, so you exclude this case. Okay, so first thing first, you consider both. Okay, you consider both the boy and girl is inside the committee. Okay, so consider both boy and girl is inside the committee. This is the same probability as part I. So if you want the girl and the boy not together, so it's 1 minus probability the particular girl is together with a particular boy. Right? Clear about that? Okay, you want the particular girl not to be in the same committee as the boy. It's 1 minus probability both are inside. Okay? If the particular boy and girl are both inside the committee, this is the same as part I. Right? The same as part I. Okay, so it's 1 minus 35 over 126. So that gives you 91 over 126. Okay, I recap. This concept has been gone through with you before, okay, in the P&C. Why they are the same? Okay, if you've forgotten, can you please look at the lecture recording is inside. Okay, the lecture recording is the math subject page. Okay, okay. So let's move on to part 3. Okay. Part 3. Right, a committee will include at least one boy. Okay, there are 2 ways to do this. Okay, which are the 2 ways? Okay, I saw one boy thinking very, very hard. Okay, still thinking super hard. The boy at the last row there, come, yes, you just look up. So beside you on the left, then the red t-shirt, yes, here. Yeah, you look at me. Yeah. Okay, so what are the 2 ways to do this? Include at least one boy. How? What are the 2 ways? I can't hear you. No, no idea. Yo, P&C have you gone through a P&C? There are 2 ways. One is the direct way. Okay, is where you consider cases. Let me write it down. Okay, the first way is complement. Okay, the second way is the direct way, where you need to consider cases. And this considering cases is very tedious. Okay, I'll write it out for you. Okay, please write it in. Alright. Please write in part 3. Okay, 2 ways, the complement and the direct way, where you consider cases which is tedious. Okay, how to find the complement? First go through a complement first. If you want at least one point, what case you don't want? The committee where there is no boys at all. Okay, so the complement way, so this is the complement way. Complement. Okay, so it's 1 minus probability, no boys. So it's 1 minus, if it's no boys inside the committee, it means it's all girls, right? Okay, if it's all girls, okay, how to choose the girls? How many girls are there in total? 5 girls, right? Okay, so 5 choose 5. Divide, because this is probability. So I want one is the total prob. Okay, minus the probability that there are no boys, so it's 5 all girls, so 5 choose 5 divide by 9 choose 5. What's the 9 choose 5? This is the no restrictions one. The 9 choose 5 is the no restrictions. Is that clear? Okay, so this gives you 125 over 126. Okay. Alternatively, here, okay, is the direct way, is where there are cases which is tedious. Okay, why is it tedious? Okay, because if you want to choose at least one boy, you need to consider cases. One boy, four girls. So this is case A. Two boys, three girls, case B. Three boys, two girls, case C. Four boys, one girl, case D. Okay? Okay, so for case A, how many boys are there in total? There are four. Okay, I only want one boy, so 4 choose 1. Multiply by what? I want 4 girls. There are total 5 girls, so 5 choose 4. So this is for case A. So let me highlight. This is for case A, case A. Plus, okay, because this process, the case A, I've completed the selection. I'm done. So I need to consider case B. But consider case B is a separate case, right? So you add. Is that clear? So you plus. Okay, 2 boys. So it's 4 choose 2 because there are total of 4 boys. You choose 2 times 5 choose 3. This is case B in blue. Okay, the blue is it too dark? Can see or not? Okay, blue. For case C, you want 3 boys, so 4 choose 3 times 5 choose 2. Follow the process. This will be in green. Then you plus last case, the case D is 4 choose 4 times 5 choose 1. This is the last case. I pick orange. Okay, so it should be orange. Okay, orange. So last case is orange. Okay, divide by what's the no restriction? 9 choose 5. Okay, so you still get the same answer, which is 125 over 126. Can you see how tedious it is? Okay, I went through the direct way with you and the complement way with you. Is that clear? Okay, so this is the overview. Okay, so let's move on to example 3. I promise you I will go back, right? So this is example 5 done, so example 3. There's a reason why I go to example 3. Okay, using tree diagram. Okay, when do you use tree diagram? Right, I'm going to write out the guide for you. When do you use tree diagram? You do tree diagram when there are stages. Okay, and one event depends on another event. Sorry, I got no space. Okay, so when there are stages, when there is a sequence, and when one event depends on another event. Okay, this is when you use the tree diagram. So let's take a look at the example. Okay, it will be much clearer for you. Okay, so this Example, the probability that it will be sunny tomorrow is 1/3. If it is sunny, then Susan will play tennis. You see, whether Susan will play tennis depends on the weather, right? Okay. And then if it's not sunny, Susan will play tennis, the probability is 2/5. Okay, so the probability changes. So this is when there are stages. Okay. Alright. So they ask you to find the probability that Susan plays tennis tomorrow. So first thing first, again, I don't know say how many times already, you need to define the event. Right? Okay, so let A be the event that is sunny tomorrow, B, Susan play tennis. Let me share this with you. Your end of the branch, this is for event. Okay, your probability should be written on top of the branch. Is that clear? Not the other way. The end of the branch is the event. On top of the branch is the probability. Is that clear? Okay. So, okay, sunny is 1/3. So not sunny A prime is not sunny. So it's 2/3. Okay. So if sunny Susan will play tennis is 4/5. So this is 4/5. Please write it down because it's not stated. Okay, you need to fill that in. So 4/5 done. So here will be 1/5 because Susan don't play tennis is 1/5 if it's sunny tomorrow. So if it's not sunny, Susan play tennis is 2/5. It's given in the question. So here is 3/5. You all can feel, right? Okay. You all very good at tree diagram one. I know. Because whenever we ACA, students score in tree diagram. Okay. So now what they want? Find the probability Susan play tennis tomorrow. Here. Play tennis tomorrow. Where is the branch? The branch is here. What happened? The branch is here. And here. Because you want Susan to play tennis. Is this clear? Okay. So the probability will be 1/3 times 40 plus 2/3 times 2/5. So this is 8 out of 15. Okay? Okay. Easy, simple. Okay, one thing to note, important. Okay. Can you write down these, cancel this out? The probability of A intersect B is what? 1/3 times 4/5. Agree? Here, this one, you cancel this out. It's probability A prime intersect B. This is 2/3 times 2/5. Agree? You all agree or not? Okay. Right? The first branch is A and then B. So A intersect B. Sunny tomorrow and Susan play tennis. Okay. I'm going to introduce you a new concept. Yeah, so please wake up. The lady there drinking hard already. See, drinking. Hello. One drink will start drinking. One issue, give me issue. Okay, here. The concept is this. Conditional probability. So I need you, okay, to go straight to conditional probability, section 5. Okay, section 5. Okay, sorry, I do skip a bit here and there, but it's okay with you, right? Okay, so this is a conditional prob. Okay, this probability is called probability A. This probability 4/5 is called probability A given B, there is a vertical line there. Okay? So PA times PB given A is probability A intersect B. This PA is your 1/3. This is your probability, this is your 4/5. And this is your probability. Okay, so the branch here is probability B given that A has happened. Alright? Clear about that? So this is a new concept. This is called conditional probability. Right? What about here? The 2/5 here. I just circled it. 2/5 here. This refers to probability of B happening given a vertical line A prime has happened. Is that clear? Okay. So that's why your probability A prime, you multiply by probability B given A prime. What is the probability A? It's your 2/3. This is probability A prime. Okay? Probability B given A prime is 2/5. That's why you multiply, it becomes probability A prime intersect B. This is section 6. Section 6. Okay, you never learned this in secondary school, but I'm telling you that the second branch is your conditional prob. Given that the previous event has occurred. Okay? Alright, so this one, you realize that event B depends on whether A has happened or not. Okay? So in this case, your probability B given A. So look at here. Look at the yellow one. Okay, so this B given A. A has happened, then probability B. Clear? Whereas probability B given A prime. This is the green one. Okay. Probability B happening given A prime. A has not occurred. Alright? Okay, can see a pattern now? Okay. Okay. So these are all conditional prob. Okay, then what about this one? What about here, the 1/5 here? Too many circles, 1/5. This is probability, one in blue, is probability B prime given A. The one in orange, this is probability B prime given A prime has occurred. Is this clear? Okay. Alright, so I'm targeting all the second branches. Okay, and I call this conditional prob. Okay, so let's take a look. Okay. So in general, this is what it means. Probability A, B given A is the probability of B occurring given that A has already occurred. Okay, so let me give you an example. Okay, can you please highlight here? Okay, highlight this part. Okay. Okay, and highlight this part. The second point. Okay, how is this formula derived? Okay. You still remember this red color one? Here, this part here. Agree? Okay. So your probability B given A, if I make it the subject, is probability A intersect B, or rather B intersect A over probability A. Let me pick out my formula. You make B given A the subject, A B intersect B given A the subject, you bring the probability A to the right. A intersect B the same as B intersect A by right in this form. So it's easier to remember. Is this clear? So this is the general formula. The one that I'm pointing. Okay? Likewise, probability A given B is, what can I use from here? It's probability A intersect B divided by probability B. B becomes A becomes B. So this is how we manipulate B becomes A becomes B. So this is another formula. Okay. So B becomes AI, A becomes B. The bottom, A becomes B. Okay. So these two are important. A given B or B given A. Apply it properly. We divide by 1, take note of it. Okay. Right. So, yeah. Okay. Another way of looking at it is that if we make use of this formula in the checkbox, okay, another way of looking at it is this. Okay. I follow here. This is the formula. I write it as such. The numerator, this is the numerator. How to find the probability? You need the number of elements in B intersect A divided by the number of elements in the second space. Likewise for the denominator. Okay? Probability A is the number of elements in the event A divided by the number of elements in the second space. The NS and the number of elements in the second space can be cancelled off. So it simplifies to this part. So basically, if you take a look, the number of elements in B intersect A divided by the number of elements in event A. So this is one way of looking at it. Okay, you don't have to find the individual probability first. You can just use the number of elements. Is that okay? Right. Right. So actually, at the start, right, the multi-hole problem that I went through with you, it makes use of the conditional probability. Okay. At the end of the entire lecture, if I have time, I'll go through with you what is the probability that you can leave if you switch to stay. Okay, I'll look it up. Use a tree diagram. If those are interested, you use a tree diagram. I suggest you use tree diagram to find the probability. Okay? Yeah, but I'm not going through now here, but it's a very interesting problem. Maybe exam come up, I also don't know. Okay, but it's doable. Okay, so let's see that example. Right. Here, okay, a die is shown. Next slide. Okay, a die is shown. once. A is the event that the number is less than 4. B is the event that number is odd. Find A given B. So, first thing first, I list out my event A. What number is less than 4? 1, 2, or 3, right? Okay. Event B is 1, 3, 5. Okay. Sample space is 1, 2, 3, 4, 5, 6. Sample space, the definition I went through in my first lecture. With all the possible outcomes, it's called sample space. Okay? So, A given B. So, how do I solve it? First thing first, okay, your probability of B, what's the probability of B? There are 3 outcomes out of a possible 6, so 3 divided by 6. Your probability A intersect B, which outcome is common in A and B? 1 and 3. 1 and 3. So there are how many outcomes? 2. So 2 outcomes out of a possible 6 outcomes. Because divide by the sample space. Outcomes in the sample space. Okay? Okay, why do I find these 2 probabilities? Because I want to use my formula. Probability A given B is probability A intersect B divided by the probability B. Okay. So it will be 2 over 6 divided by 3 over 6. So it becomes 2/3. Okay. Do you notice that these 2 is the number of elements in A intersect B? These 3 is the number of the elements in B. Do you notice that? Okay. So one way of looking at it, we use the formula probability. Done. The other way, you can find the number of elements in A intersect B. There are 2. A intersect B, 1 and 3, right? 1 and 3. There are only 2 elements. Number of elements in B, there are only 3. 1, 2, 3. So this is one way of looking at it. Is that clear? Okay. So 2 ways. Normally, apply formula is the best. You won't go wrong. Okay, apply formula is the best. You won't go wrong in that manner. Okay. Okay. Let us look at this question. I realize that I skipped section 4, right? Or not? Okay, but it's okay. I'll stick this through. Okay? I'll come back to this question. Okay. Okay. Let's move on to example 7. So let's read the question. 2 pair dice are thrown. What's the probability that some extent given that the first die is 5? The keyword, let me write down. Keyword, please write down as well. Okay? Given that. So you have to think of conditional probability. Is that clear? Right? So first thing first, you need to define. Okay, so you want to find probability A given B, right? The formula is probability A intersect B divided by probability B. What is the probability of A intersect B? A intersect B. So let's list out A intersect B. Which are 2 things that overlap. Okay. There are 2 pair dice are true enough. So A is number exceeds 10. The sum exceeds 10. So let's see. So it will be here. The sum exceeds 10. So here. Again, now extend. Intersect B. You want the score on the first die to be 5. So it'll be here. Right? Which one overlap? 11. Okay? 11. So you only have 5,6. Okay. How I write 5,6? Why do I write 5,6? It just means that 11, right? 11 is the sum. 5,6 just means the score on the first die is 5, right? 6 is the score on the second die. So I get 11. Okay? So this is one outcome. Because you throw 2 pair dice. So this must be the first die, this must be the second die. Okay? You try and work out yourself about B. Okay? I'll end off here. Okay? So today you learn one new thing. Actually, 2 new things. We learn about 3 new things. Venn diagram, tree diagram, and conditional prob. Is that clear? Okay? Okay? So that's all for me.